Hello student, I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss important trends and anomalous properties of boron. Last class I have discussed chemical properties of group 13 elements. Now I am going to discuss anomalous properties of boron. Certain important trends can be observed in the chemical behavior of group 13 elements. The trichlorides, bromides and iodides of all three elements being covalent in nature are hydrolyzed in water. Species like tetrahedral and octahedral. Tetrahedral means MOH whole 4 1 minus and octahedral means MH2O whole 6 3 plus. Except in boron exist in aqueous medium. Again I am telling you the trichlorides, bromides and iodides of all these elements being covalent in nature are hydrolyzed in water. Species like tetrahedral and octahedral except in boron exist in aqueous medium. The monomeric trihalides being electron deficient are strong Lewis acids. Boron trifluoride easily react with Lewis bases such as NH3 to complete octet around boron. As for example, reaction you can understand F3B or BF3 you can tell BF3. This is the electron deficient. It will attract electron, it will take electron. With if it will react with ammonia, then on nitrogen lone pair of electron is there. Then that electron will be taken by boron and it will form F3B NH3 means nitrogen and boron coordinate bond will be formed. It is due to the absence of d orbitals. Here monomeric trihalides being electron deficient are strong Lewis acids. Boron trifluoride easily reacts with Lewis bases such as NH3 to complete octet around boron. BF3 plus NH3, N has lone pair of electron. It forms F3B NH3 where there is a coordinate bond between N and B. It is due to the absence of d orbitals that the maximum covalence of boron is 4. Boron has no d orbital. That's why maximum covalency of boron is 4. Since d orbitals are available with aluminum and other elements, the maximum covalence can be expected beyond 4. Most of other metals halides AlCl3 are dimerized through halogen bridging. As for example, Al2Cl6, Al3 will dimer and it will form Al2Cl6 through halogen bridging. The metal species completes its octet by accepting electron from halogen in these halogen bridged molecules. Here I want to discuss one question which is asked in examination. boron is unable to form Bf6 3 minus ion. Explain. This question is asked in many examinations. This type of question is asked. Boron is unable to form Bf6 3 minus. Explain. Now I am telling you explanation. I am giving you explanation of this question. Due to non-availability of d orbitals, boron is unable to expand its octet. Therefore, the maximum covalence of boron cannot be exceed 4. Okay, due to non-availability of d orbitals, boron is unable to expand its octet. This is the main reason, non-availability of d orbitals. That's why its maximum covalence of boron cannot exceed 4. That's why it can't make a Bf6 3 minus. Now other can say important compounds of boron I am telling you. Okay, some useful compounds of boron are: first, borax, very important compound, BORAX, borax. Second, orthoboric acid. Third, diboron. Now I will explain one by one these three, because all are very important. Borax, it is the most important compound of boron. BORON, boron. Okay, it is a white crystalline solid of formula Na2B4O7 10H2O. Again you listen, Na2B4O7 10H2O. This is called boron. Okay, and this more about the boron. Na2B4O7 10H2O. This 10H2O is the, you can say, water of crystallization. In fact, it contains the tetranuclear units. This I told you, Na2B4O7 10H2O. But in fact, it contains the tetranuclear units. Tetra means 4 nuclear units, like B4O5OH whole 4 2 minus. Remember it. Okay, this is the important. Tetranuclear units, B4O5OH whole 4 2 minus. And correct formula therefore is Na2B4O5OH whole 4 8H2O. Again you listen or note down. Always you should have a notebook and pen. Again I am telling you its correct formula, that is Na2B4O5OH whole 4. Okay, Na2 is outside as a cation, and B4 Na2 is outside as a cation, and inside the bracket B4O5OH whole 4. Okay, 2 minus, and outside 8H2O. This is the correct formula, but popularly it is known as Na2B4O7 10H2O. Borax dissolve in water to give an alkaline sodium. This Na2B4O7 10H2O, this is the formula of borax, and it is the most important compound of boron. Okay, now reaction I am telling you, that with water this borax dissolves in water to give an alkaline solution. Na2B4O7 plus 7H2O. It gives 2 NaOH plus H2BO3 means 4H3BO3. 4H3BO3, that is called orthoboric acid. H3BO3 is called orthoboric acid. Here it is giving, in this reaction it will give 4H3BO3 orthoboric acid. This actually there are 3-4 compounds are there which you should know with formula. Okay. Then boric acid, orthoboric acid is H3BO3. Okay. Borax already told you, boric acid also I told you. Orthoboric acid H3BO3. Then this I told you that borax, when it reacts with water, it dissolves. It dissolves in water to give an alkaline solution. Means Na2B4O7 plus 7H2O, it gives 2 NaOH plus 4H3BO3. On heating, borax first loses water. On heating borax first loses water molecules and swells up. On further heating, it turns into a transparent liquid which solidifies into glass-like material known as borax bead. In a lab, this borax test you are doing, borax bead test, that this is actually borax bead. Okay. Na2B4O7 10H2O, on heating, this 10H2O water will go and it will form Na2B4O7 without water. Na2B4O7, this 10H2O water will go out and it will swell. Okay. And this after that again if you will heat it, then it will form NaBO2. Okay, sodium borate, it will form, plus B2O3, that is the boron oxide, and it is actually anhydride of boric. You can tell boric anhydride. B2O3 is boric anhydride. Again I am telling you, on heating, borax first loses water molecules and swells up. On further heating, it turns into transparent liquid which solidifies into glass-like material known as borax bead. Question is asked. Then reaction, easily you can write Na2B4O7 10H2O. On heating, it gives Na2B4O7, and again further heating, it will give 2 NaBO2 plus B2O3. B2O3 is called boric anhydride, and Na2B4O7 without water molecules, it is called sodium metaborate. Okay, and this NaBO2 is a sodium borate. The metaborates of many transition metals. In the place of sodium, other metal may come. Na2B4O7 is there. In the place of sodium, other metal may come. The metaborates of many transition metals have characteristic colors, and therefore borax bead test can be used to identify them in the laboratory. For example, when borax is heated in a Bunsen burner flame with cobalt oxide, COO, okay, cobalt oxide, on a loop of platinum wire, a blue colored cobalt borate bead is formed. Okay, this I have told you about the borax. Now I am going to tell about the orthoboric acid. orthoboric acid. Now its a formula is H3BO3, H3BO3, okay, orthoboric acid. Now know more about the orthoboric acid. Orthoboric acid, that is the H3BO3, is a white crystalline solid with soapy touch, with just like a soap. Here also your feeling will be like this, with soapy touch, smooth. It is aspirantly soluble in water but highly soluble in hot water. It can be prepared by acidifying an aqueous solution of borax, means Na2B4O7 plus 2HCl plus 5H2O. It gives 2NaCl plus 4BOH whole 3. 4BOH whole 3, BOH whole 3. Okay. It is also formed by the hydrolysis reaction with water or dilute acid. This BOH whole 3, this is the important. This is actually orthoboric acid. Okay. It also formed by the hydrolysis of what? Reaction with water or dilute acid of moist boron compounds like halides, hydrides, means boron halides, boron hydrides plus water or HCl, you will get BOH whole 3. Okay. It has a layer structure. Question is asked, what type of structure this H3BO3 have? Then it has layer structure in which planar BO3 molecules or BO3 units are joined by hydrogen bonding, means upside BO3, down BO3, then each BO3 will be just joined by hydrogen bonding. This is the main things. Okay, layer of BO3 will be there. Layer structure in which planar BO3 units are joined by hydrogen bonds. Okay, this question is asked. Means BO3, again BO3, again BO3, then BO3, how they will bind to each other? Then through hydrogen bonding. Okay, because in that in BO3 H will be there. Then with the OH is there, again next BO3 will come. Then this O will attract this H, means H will be in the middle and upside and down O will be there. Okay, H will be in the middle and upside O and down O, and these O are joined with B, boron. Okay, that's why many layers you will find. Boric acid is a weak monobasic acid. Here one thing I want to tell you, I told you BOH whole 3. This is actually boric acid. If you will BOH whole 3 means 3O, 3H and 1 boron, 1 B. Okay, BOH whole 3 means 3O, 3H and 1 B. Then you can write it as a H3BO3. Okay, they both are same. BOH whole 3, it is easy to remember, but actually you can write it as a H3BO3. Both are same. Now I am going ahead. Boric acid is a weak monobasic acid because H is there. Then obviously it can donate the H. Then if it will give as a H plus, then it is a it is a acid. It behaves as a acid. Then boric acid is a big monobasic acid. Basic acid. It is not a protonic acid but acts as a Lewis acid because it accepts one pair of electron. Okay, boric acid is a big monobasic acid. It is not a protonic acid but acts as a Lewis acid by accepting electrons from a hydroxyl ion. Then now can write the reaction BOH whole 3. This is the boric acid, also orthoboric acid, BOH whole 3 plus HOH. HOH means water molecules. Water behave as a amphoteric nature. It function as a acid as well as a base. Then now here it is functioning as a HOH. Then it is functioning as a base. Then BOH whole 3 plus water you can write as a HOH. H plus OH minus. Then BOH whole 3 plus 2HOH, it gives BOH whole 4. BOH whole 4, 1 minus plus H3O 1 plus. Hydronic ion H3O 1 plus. Okay. On heating orthoboric acid, if you will heat orthoboric acid above 370 K, forms metaboric acid. Again, another you can say compound of boron, you remember, metaboric acid, HBO2. Okay. This is the once I told you orthoboric acid. Then that is the BOH whole 3 or H3BO3. Now I am telling another acid of boron, that is the HBO2. And this HBO2 on further heating yields boric oxide, that is called B2O3. It forms a boric oxide, B2O3, means H3BO3. If you will heat, it will give you HBO2, metaboric acid, and metaboric acids it gives B2O3. Okay, that is the boric oxide. Now again I am going to discuss one more problem. In examination, medical IIT, this type of question is asked, even other examination also. Why is boric acid considered as a weak acid? Why boric acid is considered as a weak acid, not a strong acid, weak acid? Then explanation I am giving you. Because it is not able to release H plus ions on its own. It will release, but not by own. Then when it is not I can say releasing by own, obviously something you have to do to take it. Then that's why it is a weak, because by own it is not releasing H plus. It can release, but not by own. You have to do some things, extra effort. Then because it is not able to release H plus ions on its own, it receives OH ions from water molecules. It receives OH ions from water molecules to complete its octet and in turn release H plus ions. Okay, H plus ion. Now H plus ion, it requires electron. Then from the OH ion, electron is there. Then that electron it will take and H plus ion it will release. Electron will take and from the OH and it will release H plus ion. then this is the condition. That's why boric acid is considered as a weak acid. Now I am going to tell very important compound of boron. Actually, in group 13 elements, many you know that other members are also there, but boron has a special status. That's why here we are giving more important to the boron compound, because boron are making very important compounds that is useful in real life. That's why this boron has been given more important. Others also is there, but not as much as boron. Okay, then now I am going to discuss diboron, B2H6. B2H6 means it will dimer, BH3 will dimer, BH3 again BH3, then B2H6. Okay, its structure is very important. And okay, now just to try to understand diboron. The simplest boron hydride, BH3 is called boron hydride. The simplest boron hydride known is diboron. It is prepared by treating boron trifluoride with lithium aluminum hydride in diethyl ether. Okay, it is prepared by treating boron trifluoride BF3 plus lithium aluminum hydride LiAlH4. Al means aluminum here, lithium aluminum hydride H4. Then balanced equation I am telling you, balanced reaction 4BF3 plus 3LiAlH4. It gives 2 molecules of B2H6 plus 3 molecules of lithium fluoride plus 3 molecules of aluminum fluoride AlF3. Again I am telling you 4BF3 plus 3 lithium aluminum hydride. It gives 3 product. First product is main product 2B2H6. Second product is 3LiF lithium fluoride, and third product is 3 aluminum fluoride AlF3. A convenient laboratory method for the preparation of diboron involves the oxidation of sodium borohydride with iodine. Okay, means its reaction you can write. Again I am telling you simple method in lab. How will you prepare diboron? Then it is prepared by the oxidation of sodium boron hydride with iodine. This reaction is very important for the examination. Then here balanced equation I am telling you 2NaBH4, that is a sodium boron hydride. Sodium boron hydride, also called sodium borohydride. Then 2NaBH4 plus I2 iodine. It gives B2H6 plus 2NaI plus hydrogen gas, means H2. Okay, again I am telling you 2NaBH4 plus I2, it gives 3 product, B2H6 first, second 2NaI plus third is H2. Okay, third product is H2. Diboron is produced on an industrial scale, means a large quantity, by the reaction of BF3 with sodium hydride, NaH sodium hydride. Reaction you can understand a balanced equation I am telling you 2BF3 plus 6NaH sodium hydride. It gives 2 product, but it requires temperature 450 Kelvin. 450 Kelvin. Always you remember 273 plus T, that is called Kelvin. Okay. If you want to know degree centigrade, then 273 plus T, that is equal to, as for example here, 450 K. 273 plus T, that is equal to 450. Then T is equal to 450 minus 273. Like that way in degree centigrade also you can know. Then now here I am telling you reaction 2BF3 plus 6 NaH at 450 Kelvin, it gives B2S6 plus 6 NaF, sodium fluoride. Diboron, now you know more about the diboron. Diboron is a colorless, no color, highly toxic gas. This is very, very important. It is a gas and highly toxic gas with a boiling point of 180 Kelvin. See, 180 Kelvin means in degree centigrade it will be minus. Minus means 273 plus T is equal to 180. Then T is equal to 180 minus 273. Then see, it will go in minus. It's boiling point I am talking about. Then this is a I told you highly toxic gas with a boiling point of 180 Kelvin. Diboron catches fire spontaneously upon exposure to air. For melting, boiling point is very less. In degree centigrade, how much it will come? 273. 180 minus 273 means it will come 93. Minus 93 degrees centigrade. Minus 93 degrees centigrade. Then you can, that's why it catches fire soon. Diboron catches fire spontaneously upon exposure to air. It burns in oxygen, releasing an enormous amount of energy. It releases enormous amount of energy, means very high energy. That is the minus 1976 kilojoule per mole. 1976 kilojoule per mole. Minus means it is a delta H is minus, means exothermic reaction. Then it means its reaction, you can see B2H6 plus 3O2. B2H6 plus 3O2, it gives B2O3 plus 3H2O. Okay, it gives B2O3 plus 3H2O. Most of the higher boron are also spontaneously flammable in air. Many borons are there. Then most of the higher borons are also spontaneously flammable in air. Means it catches fire. Borons are readily hydrolyzed by water to give boric acid. Then B2H6 plus 6H2O. B2H6 is gas. Always remember, poisonous gas. B2H6 plus 6H2O, it gives a BiOH whole 3, orthoboric acid, plus hydrogen gas, means 6H2. B2H6 plus 6H2O, it gives 2BH whole 3 plus 6H2. Okay. Now, diboron undergoes a cleavage reaction, means breaking. Cleavage reaction with Lewis bases to give boric adducts. AWUCTS, adducts. Okay, that is called addition actually, just like addition, adducts, it will absorb. Okay. Then diboron undergoes a cleavage reactions with Lewis bases. Lewis bases, that is called L. In shortcut, L means Lewis. Capital L means Lewis bases to give boric adducts. Boric adducts like BH3L. L means boric acid will add. BH3L, capital L. L means Lewis bases. Then B2H6 plus NMe whole 3, NMe whole 3, Me means methyl group, CH3, NH3 will be there, then all 3H will replace by CH3 group, methyl group. Then 3H was there, then 3 methyl group will come. Then it will form N-methyl Me, shortcut we can write Me means methyl, hence you can write N means nitrogen, NMe3, NMe3. Then this thing, boron, B2H6 diboron plus 2NMe3, it will give you adduct. Adduct means, now here you can understand BH3 and 2BH3 it will give, because B2H6 was there, no? That is dimer. Then it will give 2BH3 and NMe3 will be attached, NMe3. This is called adducts. Another reaction, B2H6 plus 2CO, carbon monoxide, B2H6 plus 2CO, it gives a 2BH3CO. Then now here again you can see carbon monoxide attached, that is the adducts. Reaction of ammonia with diboron gives initially B2H6 2NH3, adduct reaction it gives, which is formulated as, this you can write in another way also, B2H6 2NH3 can be written, or which is formulated as, another way you can write BH2NH3 whole 2 plus, in the form of a complex, okay, BH2NH3 whole 2 outside 1 plus, and again 1 BH4, this BH4 1 minus, then 1 plus 1 minus, it will be neutralized. Again I am telling you, BH2NH3 whole 2 outside 1 plus, I means cation, and BH4 1 minus, that is the anion. Then you can write in this way also, B2H6 2H3 can be written in this way also. Further heating, if you will heat it, further heating gives boragine, very very important compound. Always it is asked in almost all examination, IIT, medical and engineering. This question is asked, what is the boragine? Then boragine is now this B2H6 2NH3, if you will heat it, then it gives boragine, means B3N3H6, known as inorganic benzene. Remember it, inorganic benzene. Its structure is similar to benzene, C6H6. Benzene structure is there. Organic compound, organic chemistry, if you will study, then this compound you will come to know. Then this B3N3H6, this is, its structure is similar to benzene structure. That's why it is called inorganic benzene, because here boron and nitrogen belongs to inorganic, but it is similar to B3N3. If you will add, then it will come just like a C6, carbon 6 was there in benzene, C6H6. Then here B or N behave like same way. Okay, BN alternative 3 bond will be there, alternative BN. Then it will just behave like a carbon. 6 carbon is equal to 3B and 3N. Behavior is same. Then B3N3H6, known as inorganic benzene, also called boragine. Don't forget. Okay. In view of its ring structure with alternate BH and ANH group, it is called inorganic benzene, alternate BH and NH group. Then boragine I have told you. Then reaction you can see, B2H6, 3B2H6, that is the boragine, 3B2H6. Okay, this not this boragine, B2H6 boron. Then 3 molecules of boron, 3B2H6 plus 6NH3. It gives 3 molecules of BH2NH3 whole 2, that is the plus cation, and BH4 1 minus, that is the anion. Already I told you, same thing is here. Okay, then 3 molecules when diboron, 3 molecules of diboron react with 6 molecules of ammonia, it gives 3 molecules of BH2NH3 whole 2, that is the 1 plus cation, and BH4 1 minus, that is the anion. And this, on further heating, it will break and it will give a boragine. Boragine means B3N3S6. Okay, boragine. And this is called inorganic benzene. Plus one more product is there, that is the hydrogen gas. Too much hydrogen gas, it will give 12H2. Okay, this I have told you about the how boragine is made. Boragine, inorganic benzene. Now come to the structure. Structure is very, very important. Structure of this B2S6 diboron. And here why it is important, because here bond formation is very peculiar. I will tell you the structure of diboron is that by diagram you can understand. I will try to send the diagram. Here BH3, total 6 hydrogen is there. BH3, it is dimeride, then 6 hydrogen is there. Then now question arises, how they are dimerizing, how they are making dimerize, how they are coming close, how both are joining to each other, BH3. Then B is the boron is the electron deficient. BH3 is the electron deficient molecule. Then 2BH3, how they are joining? No boron has a electron. They are even electrons are not there. Sufficient electrons are not there to make octet also. Only 6 electrons are there. BH3. 3 boron has 3 electron and 3 hydrogen has 3 electron. Total 6 electron. Then how both are joining? This is the question. 6 electrons only are there, even octets are not completed. Then how they are BH3 are joining? How they are making bond? This is important. This you have to understand. Then here you have to understand like that 2 BH bond is you can understand easily. There is no disturbance in BH and BH. Out of 3 BH bond, 2 just you consider as a normal. Third one now you have to consider. Same way other BH3 also. 2 you consider as a normal. Third one you consider, you have to think over. Okay. Then see, 4 you have to not think. All four hydrogen bonds and boron are in a one plane. Correct? 2 hydrogen bond of one boron and 2 hydrogen bond of other boron. Correct? Then 2 plus 2, 4 hydrogen and 2 boron. All are in one plane. Then now that one hydrogen is left out, then one will be above plane and other hydrogen will be down the plane. And then how they are connecting the boron? Each other. then this connection is due to this hydrogen only. Both borons are connecting to each other due to this hydrogen only. But this hydrogen electron is also bonded with boron. Third hydrogen is also attached with boron only. Then how both borons are connecting? Who is playing the role here to connect? Then here role is of upside boron, upside hydrogen and down hydrogen. One hydrogen is there, their role is there. And here you should know that boron is 1s, 5 electrons are there, 1s square, 2s square, 2p1. Means in second orbit 2 plus 1, 3 electrons are there. Then 2s square, 2p1. Then in p only 1 electrons are there. But px, py, pz, 3 orbitals are there. Then only in 1 electron is there, 2 are vacant. Then 2s and 2s means 2 electron of s, 2s and 1 p, 2p. 1 electron is there, they will hybridization will take place. Then it will form means 2 electron of 2s, 1 electron will go to the p. Then now in p 2 electrons are there, px, py, pz is vacant. Then now these 3, 1 vacant pair, 3 p orbitals are there, in that 2 electrons are 1 electrons are there in 2, 1 is no electron. Then s and these 3p, vacant p also it will take part in hybridization and it will form sp3. sp3 hybridization it will form. Okay. Then 3p plus 1s, total 4 orbitals, and name will be sp3, 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 sp3. But 1 orbital is vacant, no electron is there. Then okay, that I told you. Then here in boron sp3 hybridization is there. Then now I told you what is the role of hydrogen, how they are connecting both hydrogen. Then 2 hydrogen is there. Then actually its concept is very peculiar. Also you can tell somewhat hypothetical. Then hydrogen has 1 electron, okay, which is upside plane, above plane and down plane. Then both electron has 1 electron. Then what they are doing, this electron, sometimes it will make bond with 1 boron. Okay, suppose boron 1, boron 2, 2 borons are there. Then one time, first time when first hydrogen above is making bond with you can say second boron, that time second hydrogen down, this will make with first. Means electron will move so fast that 50% time it will spend with first boron, 50% time it will spend with second boron. Then both hydrogen will do same way. When 50% time it will be spending with first boron, then other hydrogen electron will go with the second. Like that way, when first hydrogen electron is with second boron, then down hydrogen electron will go the first. Then first will be there, both will spend electron will go with both electron, 50% time it will spend. But when 50% time they are spending, one is spending with first, then second will go to second hydrogen electron will go to the second. Like that way, always both boron will get electron. Correct? When 50% one electron is with the second one, then first will go, first electron is going with the second. then second electron will go to the first. Then like that way, every time both boron will get electron. That's why it is also called that single bond formation by single electron bond. Single electron bond, and this is also called B2S6 diboron, has banana type of structure. Fruits. Okay, I think one more time already I told you. Then now I have told you about the B2S6 structure, banana type of structure. Okay, boron also forms a series of you can say hydroborans. Okay, means hydroboron we are telling now. When they are making many hydroborans, then it is called hydroborans. The most important one is the tetrahedral boron, BH4 1 minus, tetrahedral boron ion. Okay, this is called tetrahedral boron ion, BH4 1 minus. And other is tetrahedriboron of several metals. So metal may change in the place of sodium borate, like that way other metal will come. Then tetrahedriborans of several metals are known, as for example lithium. Then LiBH4 I told you, lithium boron borohydride, sodium borohydride. Then lithium and sodium tetrahedriborans. Okay, also known as borohydride. Lithium aluminum hydride, borohydride, or you can say sodium tetrahedriboron, or lithium hydriborate. Okay, then lithium and sodium both forms a borohydrate, lithium borohydrate and sodium borohydrate. I have given the example. And how it is prepared? These are prepared by reaction of metal hydrides. Any metal hydrides you can take, as for example 2M you consider. M is the metal, maybe lithium, maybe boron, maybe lithium, maybe sodium. Then 2MH plus B2H6. M means metal, maybe lithium, maybe sodium, maybe generally lithium, barium they are making, other metal is also possible. Then 2MH plus B2H6, it will form 2M plus BH4 1 minus. Then M plus is cation, BH4 1 minus anion, where M is lithium or sodium. Then like this way borohydrides can be formed. Okay, both lithium hydride and sodium borohydride are used as reducing agents in organic synthesis. That time when we will synthesize organic compound, then this is the common reducing agents. Okay, common reducing agents, lithium aluminum hydride and sodium borohydride. And it is also useful as a starting material for preparing other metal borohydrides. This I have told about the B2S6 diboron. Now I am telling usage of boron and aluminum and their compounds. Its application is very important. Okay, usage of boron and aluminum and their compounds. Then now I am telling application or usage, both are same. Boron being extremely hard, already I told you, boron being extremely hard refractory solid of high melting point, low density and very low electrical conductivity, finds many application Okay, what are there? Actually, three quality I told you. First, it is extremely hard refractive solid. No effect of heat also, like that way. I told you around 4000 boiling point is there. 2000, 3900 something. Then now this boron being extremely hard refractory solid. Second, high melting point. Third, low density. And fourth, very low electrical conductivity. Okay, these 4 points are their important points. That's why it is in demand. It finds many applications. Now you can see for boron fiber. Boron, just like carbon fiber, boron fibers are used in making bulletproof vest. Bulletproof, you might have heard the name. Bulletproof, near the chest they are keeping. Then bulletproof vest. Okay, anywhere in your body you can keep. Then there this boron fiber is used. Boron fibers are used in making a bulletproof vest and light composite material for aircraft. In aircraft also it is used because it is lightweight, light composite material for aircraft. The boron actually it has a two isotope, boron 10 and boron 11. Then now I am talking about the boron 10. The boron 10 isotopes has high ability to absorb neutron. It will absorb neutron, high ability to absorb neutron, and therefore metal borides are used in nuclear industry. In nuclear reaction where is going on, that is called nuclear industry. There boron, this metal borides are used because it absorbs the neutron. Neutron are used in a nuclear industry as a protective shields and control rods. It is used as a protective shields because neutron it will absorb and control as a control rods. The main industrial application of borax and boric acid, now you listen. The main industrial application of borax and boric acid is in the manufacture of heat resistant glasses. Heat, wherever boron will be there, it is heat resistant. Even you will warm, heat, nothing will affect, no effect. Okay, heat as a heat resistant glasses. That is called Pyrex glasses. You might have heard the name Pyrex, glass wool and fiber glass. Borax is also used as a flux for soldering materials. Soldering metals, and so in a soldering purpose, soldering time, borax is also used. Borax is also used as a flux for soldering metals for joining purpose. For heat, again we can say this I told you for the soldering metals. For heat, scratch and stain resistant glazed coating to earthenwares and as a constituent of medicinal soaps. Again you listen, borax is also used as a flux for soldering metals. For heat, scratch and stain resistant glazed coating to earthenwares and as constituent of medicinal soaps. See the use of borax. Now you can see other uses. An aqueous solution of orthoboric acid is generally used as a mild antiseptic. Means in medicine also it is used as a mild antiseptic, or means aqueous solution of orthoboric acid. Now come to the aluminum. Aluminum use, you can just now listen. Aluminum is a bright silvery white metal with high tensile strength, very strong. It has a high electrical and thermal conductivity. Means electricity can be passed, already nowadays current passes through aluminum wire only. It has a high electrical and thermal conductivity. Heat can be passed, electricity can also be passed. On a weight to weight basis, now important things extra knowledge. On a weight to weight basis, the electrical conductivity of aluminum is twice that of copper, double of copper, when you will talk about the weight to weight basis. Otherwise, copper is more. Aluminum is used extensively in industry and everyday life. It forms alloys. With copper, manganese, magnesium, silicon, and zinc. Aluminum and its alloys can be given a shape of a pipe. You can give a shape of a pipe. Means pipe you can make. Tubes. Tube shape can be given. Rods, wires, plates, or foils can be made. Therefore, find uses in packing, utensil, making construction, aeroplane, and transportation industry. The use of aluminum and its compounds for domestic purposes is nowadays it is reduced. Nowadays people are not using aluminum. The use of aluminum and its compounds for domestic purposes is now reduced. Why? Now reduced considerably because of their toxic nature. It is toxic also. That is the negative point. That's why now in domestic purposes, nowadays it is not used. Despite that, some people are using, and one more, that is disease also happens. That is related to mind, head. And that's why nowadays it is its use is now reduced in domestic purposes. Now I am stopping only here. Next class again we will meet. Thank you.